Okay, so we're going to be learning about, we're going to divide radical expressions. So rationalizing using conjugates. Do you guys remember the real number system? That what were the two first classifications within the real numbers? Okay, here's the question, here's the answer, and I'm going to give you that answer, and I'm going to give you, here's another question. What are some examples of numbers in each class? And it's right here. So remember, the real numbers, this is the whole circle are the real numbers, all of the numbers. And they're divided in what? Irrational and rational numbers. I believe we did this at the beginning of the semester, chapter 1. So the rational numbers are the ones that can be written as a fraction, either terminal decimals or non-terminal repeating decimals. Okay? And the irrationals cannot be written as a fraction or a non-terminated and non-repeating decimal. Like pi, for example. It's a non-terminated and it's a non-repeating decimal. So these ones, the rationals can be written as a fraction and the irrationals cannot. Now, so now what we're going to be doing next is we're going to rationalize the denominator of our rational expressions. What this means is that we're going to take any irrational quantities and change them into a rational quantities. And how do we do this? By multiplying by 1. But as you all know, this is not a regular kind of 1. Okay? In particular, we're going to be multiplying by a 1 that is made out of conjugates. And let me give you the first example. We have 7 square root of x minus 3. So now, what's the conjugate of the denominator? Remember, we're going to rationalize the denominators of our rational expressions. That's what we're going to be doing. We're going to rationalize the denominator of our rational expressions. So we're going to rationalize the denominator of a rational expression. Okay, this is what we're going to be doing now. And we're going to be doing it using conjugates. And how we're going to be doing it? By multiplying by 1. But it's not going to be a regular 1. Because that 1 is going to be made out of what? Of the conjugates. So for example, in this one, what is the conjugate of the denominator? The conjugate of the denominator is what? Square root of x plus 3. Remember we said conjugate is going to be exactly the same but opposite signs. All right? So we are going to, let me write it back in here. So we are going to multiply it by 1, right? That's what we said. We need to multiply by 1. But what is this 1? This 1 with the conjugate. So this is how it's going to be. This is how it's gonna look. So we're gonna multiply it by square root of x plus 3 and the square root of x plus 3. Okay? So we are going to rationalize the denominator of our rational expressions. That's what we're doing right now. And how we're rationalizing it? Using conjugates. Multiplying by 1. But this one is this type of 1. We're multiplying by 1 that is made up of what? Conjugates. So what do I need to do here? We need to distribute. So let's do that. 7 times 3 is 21. And on the bottom, I have square root of x squared, 3 times x, square root of x positive. This is going to be negative and negative 9. Now, the numerator is exactly the same. And what happened here? Let me get a different color. This make a what? 0, right? So what do I have left? I only have left a what? Square root of x squared minus 9. And what is this equal to? X minus 9. So this is my answer. What I have left here is this number and this one. And the square root of x squared is x. And here are some examples that we're going to go over. All right, here's the next one. Six divided by 2 minus square root of 7. Let me see. I have my I have my pen here. I guess I don't have it anymore. All right. So what do I do now? I'm going to multiply it by the conjugate, which is 2 plus square root of 7. 2 plus square root of 7. So what do I get here? 12 plus 6 square root of 7. And on the bottom, you guys remember what we were doing before, the product of the sum and difference of two terms? I'm going to write it here again so we remember. Or maybe here. So we have A plus B and A minus B. And what do we get? A squared minus B squared. So we're going to apply that rule here. Right there. So what happens there? We're going to have this one squared, right? And B squared. Mm-hmm. Plus 6 square root of 7. This is going to be what? 4 minus 7. So we have 12 plus 6 square root of 7. 4 minus 7 is negative 3. We don't need that anymore. So now this is one fraction and this is the other fraction that we have, right? 12 divided by negative 3 is what? Negative 4. And 6 divided by 3 is negative 2. So this is my answer. So what I did here was, instead of multiplying, which we could do it, I went straight and I used the sum of this, the product of the sum and the difference of two terms. That's what I did there. The next one, I could do it and we multiply, so where you guys get used to both. This is a lot faster. Now, let me do the next one. There we go. So this is 3 divided by square root of 6 minus 4. Okay, so what I'm going to do is multiply by the conjugate. So it's going to be square root of 6 plus 4. We're going to distribute. It will be 3 square root of 6 plus 12. We could keep doing this. Okay, or we can just distribute. It's exactly the same. This one times this one is going to be 6 times 6 is 36. And this one times this one is 4 square root of 6. Now this one is negative 4 square root of 6. And the last one is negative 4 times 4, 16. So again, we make a 0 here. So what we have is 3 square root of 6 plus 12. Square root of 36 is 6 minus 16. That will be negative 10. And what do we need to do? We need to distribute the 10. We could leave it like this. I believe in Newton, you guys can either this way or negative 12 over 10, which is 6, and this is 5. Either way, okay? Now, let's do the next one. Number 3, we have a square root of 2 minus a square root of 3 divided by square root of 2. So what do I do now? I'm just going to multiply by the conjugate, okay? The conjugate will be the opposite of the denominator, all right? So now, what do I do? Distribute. So this one and this one times square root of 2 times square root of 2 would be 4. This is going to be minus square root of 6. right? Plus minus the square root of 6 plus the square root of 9. And we're going to divide this, and we know exactly this one, right? We know, let's do it the other way. A and B, A squared minus B squared. So this is going to be square root of 4 is 2, right? Negative 1 minus 1 is negative 2 square root of 6 plus square root of 9 is 3. And what do we have on the bottom? We have 2 and a 3. So 2 plus 3 is 5 minus 2 square root of 6, and we have a negative 1. So this is equal to negative 5 plus 2 square root of 6. All right. I do have more of this one. All right. Me. This is number 4. Sorry, this is an A plus square root of B. Okay, so I'm just going to multiply by the conjugate of the denominator. This is an A. So remember, what we are doing is we're rationalizing the denominators. That's what we're doing. We're going to rationalize the denominators and of our rational expressions. That's what we're doing. So let's multiply this. So what do we have here? We have 3 times 2 will be 6, right? And A squared is going to be 6A. Now, if I multiply this one times this one, will be negative 2 square root of AB. Now, 4 times 3 will be negative 12 square root of A. And the last one will be plus 4 square root of B. And our bottom is going to be 3 square root of A squared minus square root of B squared. So let's see. We can't do anything on the top. There's nothing that we could simplify it. So let me write it down again. Then this one is going to be what? 9A. And this one is going to be B. And that's going to be our answer. We can't do anything else. Let's do another one. When we have a square root of x divided by the square root of x minus the square root of y. So again, gonna multiply it by the conjugate of the denominator. I'm rationalizing the denominators. That's what I'm doing. So the first one, This one times this one is what? Is x. And the other one will be square root of xy. This is going to be y squared. So my answer is going to be x plus the square root of xy divided by what? By x minus y. That's going to be my answer. There's nothing else there that we could do. I'm trying to see if we have anything else. Oh, let's do this one too. Did we do anything like this? Oh, no, we haven't. Okay. 4 square root of 5 plus square root of 2 divided by 2 square root of 5 minus square root of 2. So what do we do here? I'm going to multiply by the reciprocal, not reciprocal, sorry, the conjugate of the denominator. Okay. So let's do the top first. 4 times 2 is 8, right? And the square root of 5 times the square root of 5 is the square root of 25. And the square root of 25 is 5. Now, let's do this one. This one is going to be 4 square root of 10. Now, this one, this is going to be 4 square root of 10. And the last one is going to be plus 2. This square root of 2 times the square root of 2 is 2. Now, the bottom, we know is the first term is square minus the last term is square. Okay? Now, we're not done yet. So we have 4. Oh, hold on. This is 4. 4. And this one was a 2. This is not a 4. This is a 2. 2 times 1. So we have 8 times 5, 40. 4 plus 2, 6 square root of 10 plus 2. And on the bottom, we're going to have, what is this? This is 4, right? This is going to be 4, and this is going to be what? Square root of 25. So this is going to be 4 times 5 is 20. And we know that this one is going to be 2. Oops. So 4 plus 2, sorry, 4 plus 2, 42. 20 minus 2, 18. What we could do there is on this one right here. Let me rewrite it here. We could do what we've been doing, 42 divided by 18, and we could do that. Or we could factor. So it's going to be 6. 6 times what? 7, I get 42. The square root of 10. Now I can simplify it because this is a product. So I could say 6 divided by 6 is 1. Divided by 6 is 3. So my answer is going to be 7 plus the square root of 10 divided by 3. Okay? Now, we do any with a number or tab? Yes, we did. Square root and a number. Hold on. No, let's do this one. 6, 7. Square root of 2 plus 5 divided by the square root of 3 minus the square root of 5. Again, I'm going to multiply by the conjugate. As the conjugate, it needs to be the opposite, with the opposite sign, the same terms but opposite signs. Now I'm just going to multiply. So this is going to be 2 times 3 will be square root of 6 plus square root of 10. Now 5 is square root of 3 plus 5 is square root of 5. Now our bottom is going to be square minus square root of 5 square. So the top, there's nothing that we could do here. We cannot add those numbers. The only part that we could do is this one. That we know this is what? This is 3 and this is 5. So it's going to be -2. So our answer is going to be square root of 6 plus square root of 10 plus 5 square root of 3 plus 5 square root of 5 minus 2. All right, that's going to be our answer. Now, we are going to rationalize. Our first title was rationalizing using conjugates. Now we're going to rationalize without using conjugates. So let me So here's, we're going to write down rationalizing without using conjugates. Okay? So we know that when the denominator has only one term, it's a monomial, right? So the denominator is not rationalized by the conjugate. So let me give you an example of what I'm saying. So if I have 10 divided by cubic root, okay? So the denominator only has one term. So it's a monomial. So the denominator is not going to be rationalized by the conjugate. Why? Because a conjugate requires a binomial. So instead of doing that, the denominator is going to be rationalized through multiplying by a factor that makes the radicand in the denominator a perfect square or cube or whatever the index is here, okay? So again, we cannot multiply by the conjugate because conjugates are made out of binomials. So what we're going to be doing is, the way we're going to be rationalizing the denominator is through multiplying by a factor. What factor? The factor that makes the radicand in the denominator a perfect square. So in this case, we want to multiply it So we want to multiply by a number that will be the cubic root of 2 into a perfect cube. The smallest perfect cube. So now it says here that the smallest perfect cube is what? That's the one, right? Or the same, 2 times 2 is 4, 4 times 2 is 8. So in order to make this, what do we need to do? So we need to multiply by, let me write it down. So we will multiply by cubic root of what? We have a 2, so we need 2 more. Or we could say that we're going to multiply by 4. So let's do that. We have our number. Hold on. So we have our example here is 10 divided by the cubic root of 2. So we're going to multiply it by 1. But what is our 1? Our 1 is going to be cubic root of 2 to the second power and cubic root of 2 to the second power, okay? So what do I get? I get 10 times the cubic root of 2 to the second power. And right here, what do we have? Cubic root of 2 to the third power. And what is this? This is 2, right? All right, and when I have a 10, so 10 divided by 2 is 5. So my answer is going to be 5 times the cubic root of 4. So what I did here, let me go back, is because it's a monomial and I need to rationalize the denominator, I need to multiply. I cannot multiply by a conjugate. So then I need to make this into a perfect cube. Why cube? Because this is a cubic root. So what do I need to multiply to make it a perfect cube? That's what I needed. So I multiplied numerator and denominator. So here are the exercises. So let's do them. So we have the first one that we have here is 1 divided by the square root of 2. Okay. What is going to make it a perfect square? If I multiply it by the square root of 2, because what do I get? I get a 2 numerator square root of 2. The same with this one, 5 square root of 3. If I multiply by the square root of 3, I get 5 square root of 3 divided by 3. All right? Now, 25, what? Rationalize the y, so I'm going to distribute the square root. There we go. So this is going to be 5 over the square root of y. So now I can rationalize the denominator, and this is going to be y, 5 square root of, that's going to be my answer. Most of the ones that are the square root, let's see how many I have here. Let's see what I don't have in your. Okay, let's do this one. 4 negative 5 square root of 2 divided by the square root of 11. What do? Make it a perfect square multiplying by square root of 11. So what do I get here on the bottom? 11. And this is going to be multiplied, and this is going to be negative 5 times the square root of 22 divided by 11. Okay? Now, let's do this one. It's a little bit different. Cubic root of 3x divided by cubic root of 4y to the 4th power. There we go. So what do I need to multiply by? Right here, the first one. The 4, I need to multiply by. To make a cubic, it would be by a 2, right? And this one, I need to multiply by. I have 1 left, so I need 2 more. So if I multiply numerator and denominator like this, I could get a perfect cubic root here. So what do I get on the top? 3 times 2 is 6xy squared. That's going to stay like that. And in this case, what do I get? 4 times 2, 8 y to the 6th power cubic root. Now I can do it, right? Because what I have is 2 and y to the 2nd power. Okay? Now, now we're fine. Yes, we are. Okay. Number 6. Let me do this one. This is going to be to the 4th. And we have 81 over 8. So let's divide this. So this one is what? 3 times 3 is 9. 9 times 3, 27. 27 times 3 is 81. So this is going to be 3. Right? Now, what do I need to multiply to make it a perfect one? Right now, we have 2 times 2, 4. 4 times 2, 8. So we just need another 2, right? So the top is going to be 3, the 4th root of 2. And what do I get here? 16, right? And we know it's going to be 2 on the bottom, 4 root of 2. All right. Up to, I do have some more examples. 81, that's the same one that we just did. We did the one. Oh, let's do this one. 7. So we have x divided by the square root of x. So what do I need? I need another square root of x. This is more easier. And this is over x. So what happened here? My answer is going to be a square root of x. Why? Because we are making a 1. That's why. There's one with numbers here. Let me do this one. Six, 9, 7, 8, 7 and 24. So cubic root of 7 by the cubic root of 24. So perfect cube would be 8, right? 8 times 3 is 24. So let me do that. So this is going to be 8, and this is going to be 3, right? So we know that this one is 2. Right? Now I'm going to rationalize the denominator. By what? Multiplying by, how do I make this one a perfect cube? Multiply by 3 to the 2nd power. And what do I get when I do that? Okay, this is going to be 9. 9 times 7, 63. 3. And here I get the perfect one, right? Perfect cube. So this is going to be 2 times, and this is going to be 3. So my answer will be 3 over cubic root of 63 divided by 6. I had to do. That's what I chose to do. All right. Now, I do have, okay, this is from Newton. Let me do this one. Comes straight from your homework, okay, guys? 9 from 8.5. We have 10 divided by 1 minus 6 W. All right. So let's see, 196. Let's do this part. And let me get a different piece of paper. There we go. Let's do the 196. I'm going to do my 3 method. Divided by 2 is what? 98. Divided by 2 is 49. Now 7 times 7. So I see that what I have here is 2 to the second power times 7 to the second power, right? What I could do, I see, this is what I can do. I could do this one and this one. I can combine them. So just watch. So this is going to be equal 10 and 14 is squared times W. Why 14? Because this is what we have here. 2 times 2, 7 times 7. So I combine this one and this one. That's what I did. And now, what do I need to do? Just multiply it. What would make perfect cube? Another 14, right? And W, I need 2 more. So what I'm going to have on the top will be 10 cubic root of 14 times W squared. And on the bottom, I'm going to have what? 14 to the third power and W to the third power. Okay? And we know the bottom is what? It's going to be 14W. And the top will be 10 cubic root of 14 times W squared. Now I can simplify these two numbers. It's going to be 5 and 7. This is one of the exercises from Newton, okay? All right.